This is Chapter 15, Lecture number 3. We're going to finish the chapter today by looking at the last couple of concepts. The first one is change of state. There are many processes other than chemical reactions which absorb or release energy. These are the physical processes like melting or boiling. So we're going to look at heats of fusion and solidification. All solids absorb heat as they melt to become liquid. The temperature of the solid will remain constant until the solid has completely melted. So on a heating curve, which we will look at in lab this week, this will be the lower flat part of the curve. Only after the solid is melted will the temperature of the liquid increase. So during the process of melting, which we're going to call fusion, there is no temperature change. The quantity of heat absorbed by melting a solid is exactly equal to the amount of heat released when a liquid freezes. The heat of fusion of water has a value. It's the energy needed to melt 1 gram of ice at its melting point. This value is 334 joules per gram. We can find the value in Table B. Similar to heat of fusion is heat of vaporization and condensation. All liquids absorb heat as they boil to become a gas. The temperature of the liquid will remain constant during the boiling process. Only after the liquid is vaporized will the temperature of the gas increase. The quantity of heat absorbed to vaporize the liquid is the same amount of heat lost when the gas condenses. And the heat of vaporization of water is the energy needed to vaporize 1 gram at its boiling point. This value is 2260 joules per gram. It is also found in Table B, and we can see by comparing it to the heat of fusion, it takes a lot more energy to boil water than it does to melt ice. Here is our heating curve that we're looking at in lab this week. The diagonals represent the phases, solid, liquid, and gas, and the horizontals represent the phase changes. So that leads us to our last concept, which is called a spontaneous reaction. They are reactions that occur naturally, or they work to favor products. Some reactions that are spontaneous, which means they occur naturally, at one set of conditions, may not be spontaneous at other conditions. Photosynthesis is non-spontaneous, but it occurs when energy is supplied by the sun. So carbon dioxide plus water absorbs energy to form sugar and oxygen. So what will determine if a reaction will be spontaneous? We don't have to know this equation, but we do have to know the last two terms. In a spontaneous reaction, there tends to be a decrease in energy. So energy is released, which means it's exothermic, which means it has a negative delta H. A spontaneous reaction tends to increase in entropy. Entropy we discussed earlier in the year. It's a measure of disorder. So if a reaction becomes more messy, more disorderly, it becomes more random and tends to be spontaneous. More disorder has the term positive delta S. So we'll talk more about this in class, but that's essentially it for this lecture. So we will see you tomorrow.